All right, in this video, we are going to work example 9.84 from our textbook. It says the average lactation nursing period of all earless seals is 23 days. Gray seals are one of several types of earless seals. The length of time that a female gray seal nurses her pup is studied by S. Twist et al. In the article Variation in Female Gray Seal Reproductive Performance Correlates to Proactive Reactive Behavioral Types. A sample of 14 female gray seals had the following lactation periods in days. Okay. And it says, at the 5% significance level, do the data provide sufficient evidence to conclude that the mean lactation period of gray seals differs from 23 days? Assume the population standard deviation is 3.0 days. Okay, so all right, so our procedure, right, for this test is to first off find the null hypothesis and the alternative hypothesis. Okay, so reading through here, right, they tell us some background, they give us the data, and then down here, right, they say at the 5% significance level, do the data provide sufficient evidence to conclude that the mean lactation period of gray seals differs from 23 days? Okay, so what that means is that our null hypothesis, HA, right, is that the mean differs, right, from 23 days. So that the mean is not equal to 23 days. If you haven't watched the video from 9.1, right, about setting up the null and alternative hypothesis, you need to go back and watch that. All right. Remember, then our in our class, right, the null hypothesis is always going to be mu equals, right, some number, and these numbers are going to be the same here. So that is our null and alternative hypothesis. This means that we have a two-tailed test, right? Because the alternative hypothesis is not equal. Okay. All right. Next up is decide on the significance level. Well, it's just, again, going to be mentioned in the problem. It says at the 5% significance level. All right. So that means that alpha is 0.05, right? Writing 5% as a decimal. All right, next up is we want to compute, right, the value of the test statistic, right? That's going to be z equals x bar minus mu naught over sigma divided by square root n, right? And so we need to get the sample mean, that's x bar, right? And so looking back at the problem, it says it doesn't give us what the sample mean is. It does say that the sum of the data is 274.9. Okay, so that means if you take and add all these up, you get 274.9. So all we have to do is to divide by how many we have to get the mean, right? So we have two rows, and 1, 2, 3, 4, 5, 6, 7. Okay, yeah, 14 is the sample size here. So it's 274.9. 274.9 divided by 14. All right, that's going to come out to be 19. 0.64, right, to 2 decimal places. Okay. If they hadn't given us this, the sum of the data here, then we would have to do all of that stuff ourselves. Okay. So, all right, next up, we want to subtract off mu naught. Remember, that's the number here, 23. And then we're going to divide by the population standard deviation sigma, which is 3. and then the square root of the sample size, which is 14. Okay. All right, so we'll need to calculate that out. So 19.64 minus 23 divided by 3 divided by square root 14. Okay, so that's what I get. Minus 4.19. Okay, so we have the test statistic. Next up, right, we are going to decide, well, we already know, right, that this is a two-tailed test, right? So what we're going to do next is get our p-value. All right, on our p-value, our z-score that we got was negative 4.19. So that's over here somewhere. All right, and so our p-value is going to be the area that's to the left of negative 4.19, right, and to the right of positive 4.19, right? This is a two-tailed test. All right, so we're going to have to find this area over here using table 2 and then double the answer to get this area over here as well added in there. Okay, all right, so go to table 2, look up negative 4.19. All right, so if we're looking here for negative 4.19, right, then we can see that there's no minus 4.19 on here, right? So, and if you look at this little note, it says for z's that are less than minus 3.90, the area are 0.0000 to 4 decimal places. All right, so that doesn't mean that it's 0, right? Because it's not really, but it's smaller than, right? There might be some numbers down the line here, but to 4 decimal places, it's 0, okay? And so that makes this part over here 0 as well, right? For all practical purposes. All right, so the total area, the area to the left of minus 4.19, the area to the right of 4.19, would be 2 times that value, okay? And that, again, is just going to come out to be 0 again, okay? So that's our p-value. Our p-value is 0, right? Essentially, it's really not 0, but it's very, very close to 0, okay? All right, so the next step, right, is we are going to compare our p-value to our level of significance, alpha, right, to see which one is smaller. So 0.000. We're comparing that to alpha, right, which is 0.05. And obviously, right, the p-value is less than the level of significance. And so what we are going to do, right, is to reject the null hypothesis. Right? This is an extremely rare event, right? If the mean really is 23, then the probability that you would get a sample where the mean is 0.9164 is practically 0, right? So there's no way, right? And that this is probably right, okay? So our conclusion, right, is that the data do provide sufficient evidence to conclude that the mean lactation period of gray seals differs from 23 days. Okay? So, again, about this conclusion, right? Here, remember, if you, and lots of people get confused about the conclusion they have to make, right? Remember, it all goes back to this verbiage right here. All right, here we rejected the null hypothesis. So your conclusion, if you look at what I wrote, it is straight from this sentence right here. The data do provide sufficient evidence, right, to support, right? The data do provide sufficient evidence to conclude or support, however you want to say it, that the mean, I left out the word, and now this part, where did that come from? Well, look, that's just a way of restating this stuff up here, right? What's our alternative hypothesis, right? It is that the mean, right, differs from 23. So this stuff that I wrote down here is exactly the way of saying that. The mean lactation period, so the mean is different from 23. All I did was rephrase it in terms of the problem right here, okay? So on the test, right, that's coming up, and on the final exam when you have to do this, right, this is how the answers are going to be posed, okay? They're not going to be just mu's not equal to 23 in symbols like this. It's going to be written out as a sentence, all right? And so again, it's going to be written out almost exactly like this. The data do provide sufficient evidence to, and then the alternative hypothesis. And then the data, or the other possibility, right? The data do not provide sufficient evidence, right, to conclude, and then whatever the null hypothesis is, all right? So that's key to getting those answers correct on the test is, remember what I just told you right here. It's always in one of those forms. There's going to be some other answer choices that are just always, not going to be right because they will phrase the answer in terms of the in terms of the null hypothesis. The conclusion, right, in our book and the way it's done, is that it's always going to be phrased in terms of the alternative hypothesis. These two options that I gave you right here, okay? All right. So that's it for this example.